Let's go through the intuition of limits in this video, because this is the main topic for the upcoming sessions. So what is a limit? And the thing about the limit that is confusing is because we usually say, well, the limit of this and that equals to something. But the truth is that limit is all about approaching something. So we approach a value, but we don't actually equal to that value. Approach a value. And you know, that's a matter of convention. We just say the limit equals to, because, well, that's how we do it. We just write that the limit of x approaching 3 from the positive side of f of x equals to 4. What that means is that the value that the function is approaching when x tends to 3 is equal to 4. And to prove why this is just an approach and not a value itself, not a a value that the function takes, let's draw it on a graph so we can see it better. Let's do it right next to it so we have all the picture. So for instance, if we have an xy axis, and let's say this would be the function. So let's say this would be the function. This is f of x. And we want to know what is this limit as x approaches 3 from the positive side. Well, look, this would be 3, and let's say that the limit would be 4. What does this mean? This means that when x takes values closer and closer to 3, so closer and closer to 3 means, let's say 3.2, 3.1, 3.01, let's say this is 3.2, this is the value of y, this is 3.1, this is the value of y, this is 3.01, this is the value of y, and so on. 3.001, this is the value that we approach, which is 4. We are just approaching 4, but it's not equal to 4, because we can see we have a gap in the graph which says that the function is not defined at that value. So this limit only shows that we are approaching the value of 4, but it's not equal to 4. Equal stays for the notation, because that's the convention. We're not going to write in math limit approaches. It takes too much time, too much space. We just write equals, but the notion of this equal sign means approach a value. Now besides that, what's a useful concept to keep in mind is this divisions by 0 and by infinity, because that's also kind of confusing, since in math all the time we say division by 0 is undefined, division by infinity is undefined, which is true. But again, this is not a definition. This is literally not a defined value that we're speaking about. We're speaking about an approach. So when we say something of this type, x approaches 0 of 1 over x. This is our function. This is 1 over x. And we want to know again what value we approach. Well, if we substitute 1 over 0, literally division by 0 is undefined. So that's true. But what the intuition is what is the value that we approach if we divide by a number that is very close to 0, because again, look at the arrow. The arrow literally says that x approaches 0, it doesn't equal to 0. So if we divide 1 by 0.01, for instance, let me put it in something like that. This is an example, okay? So 1 divided by 0.01, it's 100. Let's put 1 divided by 0.001, it's 1000. Do you see the trend? When we put values closer and closer to 0, so 0.01, 0.001, our result increases. So mathematically, we just show that as x becomes really small, really close to 0, our number becomes really large, and the result equals to infinity. Now, what does this mean? Well, that means that we approach infinity. And infinity, again, it's not a number, it's a concept, okay? Keep infinity in mind as a concept. A concept that stays for a very large number. That's all it is, a concept. Now, the opposite side, let's do, what if we have the same function, but x approaches infinity instead of approaching 0? So, the limit as x approaches infinity of 1 over x. Again, we write 1 over infinity. Well, we can divide 1 over infinity, right? But 1 divided by a large number, what happens if we divide 1 over 1 million, let's say? Well, that's equal to 0.000001. What happens if we divide 1 by 1 billion? We'll have a couple of more zeros. So the intuition is, if we divide 1 by a very large number, we have a very small result. And you can play in the calculator a bit just to get really this mindset that we're just approaching a value. So as x increases, as x tends to infinity, you see, x cannot equal to infinity because infinity is just a concept. But as x becomes really large, our value becomes really small. So we say that we are approaching, the equal sign just stays for approach. We're approaching the value of 0. Let's keep it this way for this video. In the next videos we'll actually apply in the questions.